Welcome to Critical Thought TV. I'm Stuart Mason Dambrot, your host. Today we'll be speaking with Dr. Randal Koene, neuroscientist and neuroengineer. We'll be talking about substrate-independent minds. Randal is the Director of Analysis and Neuroengineering at Halcyon Molecular, as well as the founder of carboncopies.org, a network focused on pursuing and consolidating substrate-independent mind research. Welcome, Randal.
Thank you. It's great to be here.
One thing I'd like to mention right away is that Randal has a very comprehensive article coming out in the Journal of Machine Consciousness later this year. And he spoke yesterday at IBM Watson Research Center on system identification, the process of explicating and unpacking, if you will, the black boxes that are common throughout advanced systems engineering. That being said, perhaps we could start with a brief tutorial on substrate-independent minds and touching on most important core issues and controversies that may exist.
Okay, sure, we can. Yeah, maybe I should explain the term first because it's probably a new term to most people.
That's a good place to start.
Yeah. So when you think about substrate-independent minds, I think a good analogy is if you think about platform-independent code when we think in terms of software. So platform-independent code is when you have a program that you can easily run on, say, a Macintosh, and you can run it on a PC and on a supercomputer. It doesn't really matter what it's running on, it'll produce the same result. Now, when we say substrate-independent minds, this is the same sort of thing we're going after. We're saying that what's happening inside of our brains is that there are functions, they are running on a certain kind of hardware. They're running on these mechanisms, on the processes that are going on in the brain. But in principle, if you can take these same functions and run them on some other substrate, some other hardware, and they produce the same result, then you get the same, well, you get the same outcome. So then what you've got is something that is substrate independent, not in the sense that it doesn't require a substrate, but in the sense that it can run on many different kinds of substrates. That's what the objective of this is about. And there are, of course, reasons for why one would have that objective, why it's important. And if you like, we can talk about that in a moment. But that's the main point. And often when I talk about this, I immediately add two other terms that are well known and that I think should be explained in terms of how they relate to substrate-independent minds. One of those is the concept of mind uploading. That's a term that's been in use in some futurist communities for a while. And it gets a little confusing because when you say something like mind uploading, then it sounds like you're taking the content of someone's mind and you may be putting it on a bunch of disks somewhere and storing it, or what is it you're doing to it? It's not quite clear. So that's why, for example, we came up with this new terminology, substrate-independent minds. And when we say mind uploading, well, we refer to the idea of taking these functions from one substrate and moving them to another. And then there are many different ways that you can accomplish that. And so because there are some methods that are more feasible today, methods that rely on the kind of science and engineering that we understand and can do at the moment, well, we look at those more than others. And in that context, there is one approach that we call whole brain emulation that is the most feasible at the moment. And whole brain emulation refers to this notion that, okay, even if we can't explain how a mind works or how anything that we do with our minds really is carried out in terms of the hierarchy of strategies that we go through from the top level of our consciousness to all the way at the bottom what the neurons are doing, if we still can't explain that, which is why the neuroscientists will always tell you, no, I don't understand how it works, I don't know how the mind works, then even if we can't understand it, we could still take the neurophysiology and the neuroanatomy at its lowest level where we understand a lot more about how to measure those variables. And if we can make that work on another substrate, if we can emulate that, just like you would emulate, say, a PC program and get it to run on a Macintosh, then you get the same emergent function, you get the same outcome. So that's why we have these three terms, substrate-independent minds, mind uploading, whole brain emulation.
So then, regarding whole brain emulation, where are we today in that process? Because one of the things I'm most interested in you and your work, one of the things that greatly interests me is that it's not just looking forward into a distant future, but it's concerned with the near term, how to actually create the technologies that allow the things we're talking about to actually happen.
Yeah,
So where are we at today in terms of whole brain emulation technology?
that's right. Okay, first I just want to say that that is indeed a distinction between ways that you can go about looking at this as a project, as a target. I never did come into this field as someone who looks at trends or looks at futurist concepts in the terms of, okay, what's likely to happen given where things seem to be trending. Instead, I came at it with that objective, with the idea, okay, this is what I'd like to do and how do we get it done? So looking at it as a project. And when you do look at it like that, then you think about the requirements. You think about what do you need to do in order to achieve substrate-independent minds. And,
I see.
and especially through that route of whole brain emulation. So what are the 4 requirements? I'm already saying 4 because we've identified 4 main requirements. And then which sort of projects can act as solutions for each one of those requirements. Now, the good thing is that in each of the 4 categories, which I can describe in more detail, there are currently projects that are addressing them. And there are multiple possible solutions. So each one of those projects, if it succeeds, solves one of the requirements. And there's ongoing research on each one of them at the moment.
That
Let me
sounds
see,
like a
where
very
should I-
good idea.
yeah.
If we pick perhaps each of the categories and then the
Right.
leading 1 or 2 projects that in your mind are the most advanced or have the most promise in achieving or helping you achieve an actual result in the foreseeable future.
Yeah, sure. Yeah, so if you want to achieve whole brain emulation, the 4 categories or 4 requirements that you really need to address, one of them is which scope or resolution do you need to look at? So if you're trying to emulate how the brain carries out functions that produce the mind, where are you going to look? Do you want to look at the function of individual neurons? Or can you even just take entire groups of neurons and say, well, we just need to see if there's activity somewhere there? So a bit of a fuzzier picture. Or can we, do we have to go deeper down? Do we need to look at specifics of the neuronal morphology and physiology and maybe even get into other cellular molecular activity? That's the resolution question. And then there's the scope question of how much do you need to take? If you want to do something where you're transferring the activity, where you're transferring the functions that are being carried out in the brain in such a manner that on this new platform, you would get the same emergent function that you could then connect with the world through all the inputs and outputs that you're used to so that the experience is the same. How much do you need to take? Is it important to take the entire cortex and the cerebellum and all of this, bring that and transport basically everything that's going on in there? Or do you need to go further than that? Do you need to think in terms of the peripheral nervous system or even the enteric nervous system? Or is there anything there that's important? So there's the scope question. The scope question, yeah, sorry.
So is there a dynamic balance between the choice or selection of scope on the one hand and resolution on the other? In other words, are they somewhat in any way codependent? If you choose greater resolution, are you allowed to somehow reduce scope and achieve a desirable outcome?
I don't really think there is. I think that they're sort of separable. The question of resolution is really about where are those functions taking place. So what is the, we're going to use this term again in a moment, currency of the brain. So what is the most important thing you're trying to capture? Whereas the scope is more about what parts are really unique, what parts are specific to the experience of having a mind, of existing, versus what is more general, what is part of the world around you. So, for instance, if you don't take along the peripheral nervous system and the way it connects to everything that our body experiences and does, then you're saying that that's generic enough that you could put in its place something else, which we already do these days when we have prostheses, for example, and that you can still consider that your own experience. So there's this sort of distinction between what are you and what is the rest of the universe. And it's a very fuzzy, gradual sort of distinction. And I find it difficult myself to determine exactly where that is.
That's a very good point, because even in the encounters in everyday life, one, for example, picks up any tool and very quickly that tool becomes an unquestioned extension of our own physiognomy.
Right.
So in that sense, the brain inhabits or embodies not just our own soma, but the tools with which we augment
Yeah.
that
yeah.
soma.
It's a really interesting thing to look at because on the one hand, nothing outside of our brain really exists from our point of view because you can't experience anything except what's being processed in your mind. You can't experience even the sensation of touch. I can't touch anything in this universe for real because the elements, like say even the protons and neutrons of the atoms that are inside the table and inside my finger, they never even collide. It's just space in between them. So all you have is forces, and they're enacting something on my body so that it eventually sends electrical signals, and I don't know that those electrical signals are there either until something's being processed in my mind. So on the one hand, none of anything exists to me unless something is being processed in my mind. That's where it all takes place. On the other hand, you've got this whole embodiment sense where the things that do end up being processed depend very much on how I'm interacting with the universe. And you mentioned using tools. I have this experience very much personally if I'm sitting in a kayak where it's no longer my legs. The legs don't matter at all. You have this feeling of there being this thing that you have complete control over, and it feels like it's part of you, and you can do all sorts of things with it. It feels very much like this is an extension of yourself. It's your embodiment.
All right, thank you so much.